Okay class, this is Ms. Taraz here again. In this video, I am going to show you how to work with equations that contain decimals. So, if we look at the equation that we have written here, I see we have 16.3 minus 7.2y equals negative 8.18. If I were speaking in more mathematically correct terms, I might read this equation as 16 and 3/10 minus 7 and 2/10 y equals negative 8 and 18/100. So an excellent strategy that you might want to consider using when you come across an equation that contains decimals is the following. So similar to my approach with fractions, I am going to put brackets around the entire equation, and then I'm going to multiply my equation by a number that will erase or wipe out all of my decimals. In this instance, I'm going to first start by looking at the decimals that I have to work with and make a decision about what I want to multiply the equation by. I'm looking and I see that I have 3/10 here, 2/10 here, and then I have 18/100 there. So this hundredths over here on the right, this tells me that if I multiply my equation by 100, I should be able to successfully clear out all of the decimals, and then I have an algebraic equation that only contains integer values. So when I do that, I'm going to draw sort of an arrow over to each term, indicating that I'm doing multiplication. I need to pick a new color to write in. How about blue? So 16.3 right here times 100, that will become 1,630. Another way to think of it is that I simply moved my decimal point 2 spaces to the right. I started with 16.3 and I moved my decimal point 2 spots, and then I filled in the 0 like that to get 1,630, or 1,630 I should say. So I'm going to actually just erase this work down here because I don't want to get in the way of the rest of my equation. Then I'm going to write in my subtraction sign. 7.2y. When I multiply that term by 100, I will get 720y equals, and then lastly, negative 8 and 18/100. For this term, when I multiply it by 100, I will get, let's see, negative 818. Okay? So far, so good. Now, I've successfully cleared the equation of all of the decimals, and I can proceed forward like I would any other equation. So I'm just going to shrink my work down a little bit, move it up top. From here, I have the sort of equation that I'm very used to working with. Remembering that the goal is always to isolate my variable, I'm going to try and get this 1,630 away from my variable, which is the y. So in order to do that, in this particular instance, I think it makes the most sense to subtract 1,630 from both sides of the equation. 1,630 over here. When I do that, on the left, those two numbers cancel out, and I have negative 720y equals, now this is a little tricky, I have negative 818 minus 1,630. I can simplify this and rewrite it as negative 2,448. So 2,448. From here, the next step would be to divide both sides of the equation by the number or coefficient in front of my variable. I'm going to underline that in a different color actually. So in front of my y, I have negative 720. So I'm going to go ahead and divide both sides of the equation by negative 720. Just showing all of my work so that my thinking is clear to myself and to you. I'm going to just drag things up a little bit. On the left-hand side, when I complete this operation, the negative 720 cancels out. And then on the right, I now have y equals negative 2,448 divided by negative 720. So before I get into the nitty-gritty of asking myself how many times does 720 go into 2,448, I already know that my answer is going to be a positive number. Now, why do I know that? I know that because we talked about this last chapter. Whenever I take a negative number, oh, sorry, I didn't mean to do that. Whenever I take a negative number and divide it by another negative number, my answer is positive. So I'm going to y equals, and then I happen to know that 2,448 divided by 720 equals 3.4. The next step in this problem would be to take your answer, which is y equals 3.4 or 3 4/10, and plug it into your original equation to ensure that your work is correct. So we didn't do that in the last video that we shared together, so I think it would be a good practice to do that together today. So my original equation, I'm going to write that in pink, was 16.3 minus 7.2y equals negative 8 18/18. So I'm going to take my value of 3.4 and I'm going to insert it into the equation where I have my variable. Let's just move that up there. So we're left with 16.3 minus 7.2 times, and then inside of the parentheses I am going to write 3.4, and I'm going to close my parentheses, equals negative 8.18. Okay, very quickly off to the side, I'm going to do, I'll do it, shrink this out and do it over here. I need to compute first I need to get my pen. 7.2 times 3.4. When I do out this math, I say to myself, 4 times 2, that equals 8. And then 4 times 7, that equals 28. So I'm going to write a 28 right here. Then I'm going to write in a different color, a 0 as a placeholder. And say to myself, 3 times 2 equals 6. I need to get my pen back. 3 times 2 equals 6. And 3 times 7, that equals 21. Then I'm going to go ahead and add all these numbers together, and I will get 8, and then 8 plus 6 equals 14. Bring down the 4, carry a 1. 1 plus 2 plus 1, that equals 4, and then the 2. Now, when it's time to place my decimal point, I'm going to count how many times I had to skip over from the right to get to my decimal points. And in total, it was 2 hops. So I'm going to hop over 2 times and get an answer of 24 48/100 for 7.2 times 3.4, this problem right here. So I'm going to go back in and plug that value into my equation right over here. So 16.3 minus 24.48 equals negative 8.18. I'm going to draw a little sliver down there so that we know that this work is sort of work I did off to the side. Reinforce my negative sign. Now, 16.3 minus 24 and 48 hundredths. This operation over here, I'm taking a value, 16.3, and away from it, subtracting 24 and 48 hundredths. I'm taking a smaller value and subtracting a larger value. So it makes sense that my answer would be a negative one. To find the solution to this operation, I'm going to actually find the difference between the two numbers first, and then decide what sign to use. So I am going to subtract, start with 24.48 and take away 16.3, and I'm going to add in a 0. So when I do that, I get 8. 4 minus 3 is 1, bring down my decimal point. 4 minus 6, I need to borrow from the tens place, so my 2 becomes a 1. Now I have 14 ones. 14 minus 6 equals 8, and then 1 minus 1 is obviously 0. So the difference between 24 and 48 hundredths and 16 and 3 tenths is 8 and 18 hundredths. As I sort of mentioned before, because we're starting with a smaller, a value with a smaller absolute value, our answer will be negative. So I'm going to include a negative sign in front of my number. So I have successfully checked out the work. I just showed that still getting used to the program, you guys. I have showed that 16.3 minus 24.48 equals negative 8.18. And then from there, I think I would just, I'm going to pick a new color, something new. Oh, yellow. I haven't used yellow yet. And just write a big check to show that I checked out my work, and in fact, my answer or my solution is correct. So y equals 3.4. We're going to just to recap and move back to the original intention of this video. We see how I started with 16.3 minus 7.2y equals negative 18 or 8.18. And from there, I multiplied every single term in the equation, or I could say I multiplied the entire equation by 100. In doing that, I cleared away all of the decimals so that I was able to work with simpler integer values, and ultimately found the solution, which was that y equals 3.4. And it's no surprise that I wanted to get rid of my decimals, because as you saw down here, when I was checking my work, the decimals made it much more time consuming and more complicated. So I think whenever possible, it's a good strategy to remove the decimals from the equation if possible. So that is the video I am sharing with you today. As always, if you have any questions or you want more clarity on this topic, respond in your math journal or come to class with questions ready that I can answer.